is going to be what's called your sum and difference formulas. Okay, I'm going to write down just a few of them so you can kind of see what I'm talking about, but really look on your reference sheet here for them, so I can find them. All right, now they're written differently on your reference sheet from your textbook. All right, so they have, it's 6 of them here. I'm not going to write all of them down, but they have like sine of A plus B is equal to sine A cosine B plus cosine A sine B. Now, what your book does, instead of using A and B, they use the Greek letters. They use alpha and beta. Okay, y'all remember what alpha looks like? A little fishy. Okay, so they'll use that instead of A. Now, do y'all see what I'm talking about on your reference sheet now? All right, right there. Now, keep that in front of you the whole lesson, okay? Because everything's going to go off of this. And these are called your sum slash difference identities. Okay, now, part of what it's there to help me do is to find more exact values that aren't necessarily on my unit circle. Okay, now ultimately we'll start memorizing a lot of these values, but to start off with, we're going to use these sum and difference identities to kind of get to them. All right, so for example here, let's start off with, let's find the exact value of the cosine of 11 pi over 12. Okay, now it's kind of easier to do when it's in degrees. I probably should have started off with a degree example. You want me to do that? All right, let's start off in degrees. I'm sorry. All right, and then we'll switch to the radians. Although the radians is not too bad. Let's look at this one. The sine of 75 degrees. Okay, so now what I want to do is I want to use the sum or the difference formulas to get to 75 degrees. Yeah, have a seat right there. So what we're going to do is look on our unit circle and ask, all right, what's a couple of angles that we've got on our unit circle that would give me 75 degrees? Okay. So what angle plus another angle would give me 75 degrees? All right, 45 and 30, or 30 and 45, either way, right? You go. You can use that one. All right, so we said 30 and 45 would give me that 75, right? And so I'm going to write down this formula here. Notice I'm going to add the two angles, right? Now, if I wanted to, I could find two angles that subtracted to be 75, couldn't I? And so in that case, I'd be using that other formula here, the difference formula instead, the A minus B. Okay? But we're going to do the A plus B. Usually I like to use sums more than difference because it's easier to add than it is to subtract. Okay? So we're going to do this. We're going to write down this formula right there, the sine of A plus B down here. So I'm going to write down sine of A times cosine of B plus cosine of A times sine of B. Okay? And now what we're going to let A and B be here is those two angles that we just mentioned that would add up to be 75. All right, so we said what, 30 and 45. So we'll let the A one be 30, 30, and then the B one be 45. Okay, so I'm going to do this like above it. I'm going to write 30 degrees there, 45 degrees there. All right, but don't get them backwards. 30 degrees there, 45 degrees there. And now all we have to do to evaluate this is just look on our unit circle. Okay, so what's the sine, y'all, of 30 degrees? All right, a half. Okay, what's the cosine of 45 degrees? Square root of 2 over 2. And then the cosine of 30 degrees is square root of 3 over 2. Is that right? All right. And then times the sine of 45 degrees, which is square root of 2 over 2. Okay. And now all we have to do is just evaluate this here. Okay. So a half times square root of 2 over 2, that would be square root of 2 over 4. And then that other one's going to give me what? Square root of 6 over 4. All right, now notice I have a common denominator, but can I add square root of 6 and square root of 2 and get square root of 8? No. Okay, but we could write them as what? Both over 4. So this would be square root of 2 plus square root of 6 over 4. Okay, and later on, once we start doing these, and I'm going to kind of establish this tomorrow, we're actually going to start memorizing that because it's going to be to our advantage if we memorize it. But we're going to derive them out first. Yes. It wouldn't let you enter it in like that, but it lets you do it that way. All right, try it both ways. All right, but you know, usually all of these are going to have something like this. Okay, it might. The only difference is it might say sometimes negative square root of 2 plus 6 over 2. That's the other version. Okay, now let's do one that's in radians, and then we'll do a tangent one. All right, tangent's kind of nasty. Now let's do the cosine of 11 pi over 12. This is the one we started with, but I said, oh, let's do a degree first. All right. So now it's kind of harder when you're in radians because you have to deal with fractions, don't you? Now, the best way to think about this is to look on your unit circle and to think of every angle that's in radians as in something over 12. That way you have a common denominator. Because notice, if you got your denominators are always either 3, 4, or 6, aren't they? And so the common denominator would be 12. Okay, so let's try to think of two numbers here that we can get to get 11 pi. Okay, all right, 5 and 6. All right, now do we have a 5 pi over 12 though? No. Okay, so let's try to think about two other numbers. Let me think just a minute. What'd you say? All right, I think that'll work. Well, we don't have, yeah, we do. All right, here we go. 9 pi over 12 and 2 pi over 12, right? All right, that would give me 11 pi over 12. Now, 9, because I'm trying to get to 11 pi, okay? I'm trying to either add two angles or subtract two angles to get 11 pi over 12, okay? And see, now if we reduce these, this would be 3 pi over 4 and pi over 6, wouldn't it? Now, aren't those on my unit circle? Okay, so now we can use this. Now, look at your reference sheet and look at the sum formula for cosine. Okay, so you have cosine of A plus B equals, all right, cosine A times cosine B minus sine A times sine B. Okay, now the ones that we want here, we want the A and the B one to add up to be 11 pi over 12. And so we said that would be what? 3 pi over 4 and pi over 6. Okay, so which one do y'all want to be A? The first one? Yeah, it's not going to matter. And you know, if we wanted to, we could have found two angles that subtract to do that too. Okay, but you know, I'm going to add first before I would want to subtract. All right, so we're going to let A be 3 pi over 4, and then the B is going to be pi over 6. Okay, so now what's the cosine here of 3 pi over 4 would be negative square root of 2 over 2. All right, and now cosine of pi over 6 is square root of 3 over 2. And now the sine of 3 pi over 4, yeah, square root of 2 over 2 times the sine of pi over 6, which is a half. Okay, now let's multiply these out here. So this will give me negative square root of 6 over 4 minus square root of 2 over 4. All right, so I could write that as negative square root of 6 minus square root of 2 over 4. Okay, now if this right here kind of bothered you a little bit, y'all try to think what's an alternative there you could do if you couldn't deal with the fractions and the radians. You could change it to degrees. Okay, and it's really easy to add degrees because they're always whole numbers instead of fractions. Okay, so that's an option. Now let's look at um, one with tangent, because tangent, he's kind of nasty. All right, let's do the tangent, the exact value here for the tangent of 75 degrees. Okay, now so you want to add two angles again, so we can add what, 30 and 45. All right, now y'all look at your reference sheet, look at the sum identity for tangent. Okay, so you get tangent A plus B equals tangent A plus tangent B over 1 minus tangent A times tangent B. Okay, so to get 75 degrees, all right, y'all want to use what, 30 and 45 again. Okay, all right, so let's write these over here, and then we're going to start evaluating. All right, so this one we're going to put 30 there, and then 45 there. Okay, so let's see, tangent of 30 degrees. All right, now I can't remember. You'll have to is either square root of 3 or square root of 3 over 3. Square root of 3 over 3. Okay, so you got square root of 3 over 3 plus, now this works out pretty nice. That's just going to be 1 over 1 minus, now tangent of 30 degrees again is square root of 3 over 3, and then times 1. Now this gets pretty nasty right there, but I'm going to show you an easy solution around this that your book won't show you. All right, before I do what I'm fixing to do here, I'm going to go ahead and multiply that out. Okay, so we're going to have square root of 3 over 3 plus 1 over 1 minus square root of 3 over 3, because square root of 3 over 3 times 1 is just square root of 3 over 3. Now, let's see if you guys can remember. Remember, these are called complex rational expressions. We have a fraction over a fraction. What's one way to go through and just sort of clear out a bunch of stuff? Common denominator. We can multiply through by the common denominator, and it really cleans it out, doesn't it? And so that common denominator would be 3. All right, so we're going to multiply everything by 3. Okay, what about the 1 over here? Yeah, even that one. The only thing there is just not going to cancel out, is it? All right, so now that's what's going to happen. These 3's are going to cancel, and so I'm going to have square root of 3 plus 3 over 3 minus square root of 3. All right, but we still have some issues, don't we? Yeah, you have to rationalize. All right, and so I told you tangent would be kind of nasty there. All right, so we've got to take it and rationalize it. So how do we rationalize something like that? We're going to multiply it, now not by square root of 3 over square root of 3, but you have to do it by the conjugate, which would be 3 plus the square root of 3. All right, this is algebra 2 right here, okay? Now, so multiplying by square root of 3 over square root of 3 is not going to get it when you have an expression down there. Instead, you have to multiply by the conjugate. And so if you have 3 minus the square root of 3, the conjugate will be 3 plus the square root of 3. Now we're going to have to FOIL this out up top here. So I got square root of 3 times 3 would be 3 square root of 3. And then square root of 3 times square root of 3 would just be 3. And 3 times 3 would be 9. And 3 times square root of 3 would be another 3 square root of 3. Didn't I tell you tangent was nasty? All right. Now, what's the deal with conjugates, though? A lot of stuff cancels. So all you have to do is multiply what? First and last. All right. First is going to give me 9, and last is going to give me -3. Okay. Now, let's clean this up. All right. On the numerator there, 3 square root of 3 and 3 square root of 3 would be 6 square root of 3. And then 3 and 9 would be 12. All right, in the denominator, 9 minus 3 would be 6. And now we can, cancel out by 6. So that would be square root of 3 plus 2. And that's it. Okay, now remember what I told you about tangent? It's nasty. And the reason why it's nasty is because you get, go back, you're going to get a complex rational expression. Remember what we did, multiplied by the common denominator? All right. And then what else happened that was nasty that we had to do? Right here. Yeah, you got to rationalize by multiplying by the conjugate. Okay. Now, all right, but I'm going to tell you in a little bit here, probably more so tomorrow or the next day, what we're looking at is we'll start memorizing these. Okay. And so when it gets quiz time and test time, a lot of these we're not going to have to work out because we're going to have them memorized. And really and truly, all you have to memorize is about 4 numbers. Okay? Yes. Yeah, but we canceled everything out. Okay? It's kind of like this. All right? We're splitting it basically. Does that kind of make sense there now? Okay. So remember, I know it's adding and we're not supposed to cancel with adding, but the thing is we're canceling on all 3 terms, aren't we? So that makes that okay. All right. Now, let's look at some that's actually pretty simple here. Okay, so I'm going to use my sum and difference identities here to kind of help me evaluate these. All right, let's evaluate here. And we're going to find the exact value again. All right, the sine of 80 degrees times the cosine of 20 degrees minus the cosine of 80 degrees times the sine of 20. Now, you'll love these problems because all you have to do here is figure out, well, which sum or difference formula are they using? And by the way, you don't have to memorize sum and difference formulas. You will have a reference sheet on this. It won't be our reference sheet, but it'll be a reference sheet from ULM. And so you don't have to memorize. It'll be a lot of stuff on this next test that you won't have to memorize. All right, so let's notice, all right, which one are we using here? All right, the sine of A minus B is what we're using, okay? And so which one is the A and then which one is the B? That's the A and then that's the B, okay? And so y'all said this would be the A minus the B one. And so all we got to do is put these in. So this would be the sine of 80 minus what? 20, which is 60. And now we can evaluate that, can't we? All right. What's the sine of 60 degrees? Square root of 3 over 2. Okay. Now what's nice about this, you can do this. You can like throw all that in your calculator, and it'll give you the decimal approximation for square root of 3 over 2, and you can check it. Okay, but those are really, really easy problems right there. Okay, it's kind of like the opposite of what we just did, isn't it? You know, kind of get that feel. It's like just the opposite of what we did first there. All right, let's do a tangent one. Now even tangents are easy. Okay, let's do tangent of 25 degrees plus the tangent of 20 degrees over 1 minus the tangent of 25 degrees times the tangent of 20 degrees. All right, let's find this exact value. So it's obviously tangent, right? So is it the tangent, is it the difference or the sum? All right, yeah, it's the sum. So it's the tangent of A plus B. And, you know, I'm using A plus B. We automatically get used to doing this because this is the way it'll show it in the homework, alpha plus beta. Okay, instead of A plus B, they'll use alpha and beta. All right, now, so what's my alpha and what's my beta here? 25 and 20, right? So it's be the tangent of 25 degrees plus 20 degrees, which is 45 degrees, right? Right. Tangent of 45 degrees is just 1. All right. So, yeah, I'm loving those problems. Okay, those are pretty simple. Now, let's look on working for another exact value here. And we're going to find several off of this one. This one will take us a while to do, okay? So, again, I'm not going to write the directions, but I'm going to say we're going to find a bunch of exact values. Now, let me give you some information here. Let's say that we got the sine of alpha is 4/5, and we're going to be told here alpha is only going to range in one quadrant, okay? It's going to go from pi over 2 to pi, okay? And now we're going to be given this here. The sine of beta is going to be -2 over square root of 5. And beta is going to be in between pi and 3 pi over 2. Okay, so what they're basically telling me is what quadrants I'm in. Okay, now in a minute here, what we're going to do is we're going to find 4 things, and I'm going to write them at the bottom. We're going to find the cosine of alpha, we're going to find the cosine of beta, we're going to find the cosine of alpha plus beta, that would be the sum identity, and then the sine of alpha plus beta, that would be the sum identity for sine. Okay, so y'all think about it. All right, how could we find what I said first there, the cosine of alpha? And you remember, I don't know if I've told you guys this before, but you know, a lot of times if they tell you what quadrant to be in, that's a big hint to draw a triangle. Okay, now they do it with Pythagorean identities, and I don't do it that way. But did you notice that they're basically telling you what quadrant to be in? What quadrant are they talking about there? The second quadrant, and then beta is in the third quadrant. Okay, so what we're going to do is basically draw triangles to figure this out. Okay, so we're going to draw a triangle in the second quadrant. Okay, and this will be for alpha. So there goes my second quadrant triangle, and there's my alpha. Okay, now, oops, sorry. Like I said, the second quadrant, not the third. All right, I'm sorry. My bad. Here we go. All right, so there's fishy. All right. Now, so it says the sine of alpha, I should have put an equal sign there, is 4/5. All right, sine is what? Opposite over hypotenuse, so that's 4, that's 5. And so the bottom leg, think about it again, it would be -3. Why is it negative? Because it's going to the left. Okay, so you got to be really, really careful on your signs here. Okay, so now, can y'all tell me what the cosine of alpha is now? Adjacent over hypotenuse, so it would be -3/5. Okay, now let's do the same thing for beta, but on beta, we're going to draw another triangle. Now, beta is going to be in the third, right? Okay, so we'll put beta in the third quadrant. All right. Now, sometimes it bothers people that this is not rationalized. And what I'm going to say about that is what you want to do is you want to look at probably the rationalized version and the unrationalized and probably use what's easier. Okay? Yeah, the unrationalized version is easier. Now, it would rationalize what? -2 square root of 5 over 5. Now, that's actually easier to use. And so there's one in your homework here where they give you the rationalized version. It's actually easier to use the unrationalized one, okay, when you write your triangle out. Now, and I'll mention that here in a minute as to what it is. It'll kind of help you out a little bit. All right, so let's see. We got beta, and the sine of beta is -2 over square root of 5. So opposite over hypotenuse. Okay, is that right then? All right, now let's find the other leg. So the other leg would be an x coordinate, right? So x squared plus what? 4. -2 squared is 4 plus square root of 5 squared would be 5. So we get x squared to be 1. So, all right, that's going to be 1, but -1. Why is it negative? Because it's going to the left. Yeah. Okay. Now, so now can you guys tell me what the cosine of beta is? All right, let's see. Cosine is what? Adjacent over hypotenuse, so it would be -1 over square root of 5, which would be negative square root of 5 over 5. And there again, I'm always going to use whichever one is sort of convenient. Okay? But if I enter it in as a final answer, it has to be rationalized. Okay, just keep that in mind. Now, let's find two other things. And so on these problems, they're going to ask you to do 4 things. They're probably going to ask you to find the cosine of theta and the cosine of beta, or cosine of alpha and the cosine of beta. Now, let's see if we can do this. Let's find the cosine of alpha plus beta. Now, that's the sum identity, right? So on our reference sheet, it's what? The cosine of A plus the cosine of B, but it's the same thing, okay? And so cosine of alpha plus cosine of beta, I'm going to look at my reference sheet at cosine of A plus cosine of B. So that'd be cosine of alpha, cosine of beta, and then what? Minus, is that right? Yeah, minus sine of alpha, sine of beta. Now, do you kind of see why they wanted you to find this and this first? Right, so you could do this one now, can't you? All right, so y'all help me fill all this stuff in. All right, cosine of alpha. Yeah, all right. All right, cosine of beta. It's 5 over 5. And I'm probably going to do this because it's going to give me a common denominator if I use this one instead. So the rationalized version there. And then minus, all right, sine of alpha, look back at, that was given, right? All right, 4 over 5, so 4/5 times the sine of beta, -2 over square root of 5. Now, what's better? Probably the rationalized version. That way, all the denominators are going to be 5s. All right, so -2 square root of 5 over 5. All right, now let's multiply. This is going to give me a positive 3 over square root of 5. Now, it's not going to be over 5 because I'm multiplying there. It'd be 25. And what we multiply before we subtract, don't we? Now, the next one's going to go ahead and say plus. Y'all see how that's going to give me plus there? Because we're saying what's going to happen when I multiply these two? It's going to be positive. Okay, so that'll give me what? 8 square root of 5 over 25. And so 3 square root of 5 and 8 square root of, well, wait a minute. I messed up. I don't know. Because Danielle told me to. Danielle, that wasn't right. All right. 3 square root of 5 and 8 square root of 5 would be 11 square root of 5 over 25. Okay, now these are a lot of work. I'm not going to say that they're not, but they're really not that difficult. Sum and difference identities to me have always been sort of easier than what they've looked. Okay, now they didn't ask this particular one here, but let's do, for the sake of practice here, let's do the tangent of alpha plus the tangent of beta. Okay, so I'm going to do this. I'm going to copy this. And let me paste it here. All right. Now, let's find the tangents here. Okay. So y'all help me find, that all stuff go away there, the tangent of alpha and the tangent of beta, if I had to do that. Hang on. It won't go away. Hang on, let me try this. Hang on. There we go. Now I got to make it. All right. All right, guys. What's the tangent of alpha now? All right, -4/3. All right, the tangent of beta would be 2. Okay. All right, so now let's find on this one the tangent of alpha plus beta now. Okay, so I'm gonna look at my formula first here. That's the sum formula for tangent, right? So you'll look on your reference sheet. Okay, and you're gonna get used to these, and probably sooner or later you'll actually start memorizing your sum and differences a little bit. Okay, probably not enough to know them, but enough to kind of catch on to a pattern to them. All right, so this is equal to what? The tangent of, I lost it, alpha plus tangent of beta over, what is it, 1 minus or 1 plus? 1 minus tangent alpha tangent beta. Okay, now let's plug all this in. So tangent of alpha was -4/3. I got -4/3 plus the tangent of beta was 2 over, right, 1 minus tangent of alpha times tangent of beta. So that's -4/3 times 2. Now I'm gonna do that multiplication there in the denominator. Ooh, this is getting long. All right, so that would be 1 plus 8/3. Now, y'all remember what we did earlier with tangent? All right, we multiplied, it was a complex rational expression, so we multiplied everything by 3. Now this time I'm just not going to show it, okay? So if I multiplied everything by 3 here, this would give me what? -4 plus 6, all right, over 3 plus 8. All right, and so that's going to give me 2 over 11. All right, remember what I told you about tangent? He's nasty. Okay. Yeah, I mean it just takes longer to do tangent. Now, one of the problems that I saw, and I was doing this off of y'all's homework, not mine, because mine kind of shows up different a little bit. I couldn't get to mine for some reason. Let me go back. Okay. And I'll PDF this for you, okay? And send it to you along with a video, send some video. All right. Now, this one in particular here, the one I saw in your homework was like this. They had 8 square root of 89 over 89, so it was a pretty awful number. All right, what would be the unrationalized version of that? The 8 over the square root of 89. Think about that. So you leave this number and basically put the square root one on the denominator, okay? And so it may be to your advantage, especially when you draw your triangle, to do the unrationalized version, okay? Now, another thing here that they're going to ask you is a ton of stuff in this lesson is to verify some more identities, okay? But what's really easy about them is you know which identities they're going to use. They're going to use sum and difference, okay? So let's see if we can verify this one. All right, so we got the sine of 3 pi over 2 plus theta equals negative cosine theta. So remember, this it'll be multiple choice, okay? But I'm not even going to show you the multiple choice. We're actually going to do this out. Now, do you recognize what identity here to use? The sine of A plus B, or alpha plus beta, okay? And so we would call probably what the 3 pi over 2 we would call the alpha, and then the theta we would call the beta. That rhymes. All right. Now, so let's write out our formula here, okay? So the sine of alpha plus beta, all right, what does it look like? Let me write it down here. Sine of alpha plus beta. Okay, so it's sine alpha times cosine beta plus cosine alpha times sine beta. Okay, now that's my formula, but now let's fill it in. Okay, so this would be sine of 3 pi over 2 times the cosine of theta, okay, plus the cosine of 3 pi over 2 times sine of theta. Okay, now let's clean this up. Now, we can evaluate that, can't we? Because we know what the angle is. All right, so y'all tell me, what's the sine of 3 pi over 2? -1? Is that right? All right, so it's -1 times cosine of theta, which would just be negative cosine theta, right? So they may write it like that. Now, look what's going to happen on this one. The cosine of 3 pi over 2 is 0, right? And so this would be 0 times sine of theta, and 0 times anything is just going to be 0. So this would leave me with negative cosine of theta. Now, is that what I was supposed to prove there? Yeah. All right. So these are actually pretty simple to verify. These are a lot easier because you know that they're going to use a sum or a difference. All right. And this gives it away right here. Okay. That I was using the sum identity there for sine. All right. Let's do one with tangent. Okay. Oh, I didn't write what it was supposed to equal though. Yeah. Okay. Let's do this one. Let's verify that the tangent of 2 minus theta is equal to the tangent of theta. Okay. Now, do y'all spot what the sum identity for? Nope. I'm sorry. It's not the sum. It's the difference identity for tangent. Okay. So let me write that down, and we're basically just going to fill it in and figure it out. So the tangent of alpha minus beta is equal to, right, tangent of alpha minus tangent of beta over 1 plus tangent alpha tangent beta. And I didn't copy this down right. It may be that that's supposed to be negative tangent up there. Okay, we'll see. Let's see if it works out to be tangent or negative tangent. Now, so what's our alpha here? 2 pi, all right, and then our beta is just theta, okay? Now, do y'all just you want to erase alpha and beta and just fill them in now? Or just write them above it? So I'm going to put right here, what, 2 pi, and then this one's going to say theta, same down here, 2 pi and theta instead, all right? So, y'all, what's the tangent of 2 pi? Sine over cosine it. 2 pi is 0 over 1 would be 0, okay? Minus tangent of theta over 1 plus. Now, remember we said earlier that the tangent of 2 pi was 0. And so does it even matter what tangent of beta is, really? No, because it's just going to go away. Okay. Yeah, I think it was supposed to be negative up there. Okay. And so 0 minus tangent of theta would be negative tangent theta. And then look what I'm going to get on the bottom. Yeah, just 1. So would be it. All right, those are some of the easy identities because you know which identity you're going to use before you start the problem. Okay, now let's do one more. Or here, you just want me to stop and video the last? Okay. All right, I just have one more. Okay, this is the last example here. So you can kind of tell it's another obvious sum identity. This is the sum of the sine identity. Now the only difference now is that they're using inverses in here. So we're going to do this. We're going to let the inverse cosine of a half be alpha, and then inverse sine of 3/5 be beta here. Okay, so if I've got inverse cosine of a half equals alpha, I can take the cosine on both sides, and so that means the cosine of alpha is 1/2. And now on the other one, same idea here. I can let the inverse sine of 3/5 be the beta angle. Therefore, 3/5 would be the sine of beta. Okay, and so now let's use our sine of alpha plus beta. But one of the things that you'll see that I need here is I'm going to need not only the cosine of alpha, but I'll also need the cosine of, or I'm sorry, the sine of alpha. I've got cosine of alpha, but in our formula, we're going to need the sine of alpha. So we'll skip down a little bit, and we'll leave some room here to kind of figure that out. But let's look here. We're going to do now the sine of alpha plus beta equals, let's see what that identity says here. This would be sine alpha times cosine beta plus cosine alpha times sine beta. Okay, so notice in our formula, well, we don't have the sine of alpha. And another thing is we don't have the cosine of beta either. So I'm going to need to find those. And the way I'm going to find them is just to draw a triangle. Okay, so notice if we do inverse cosine, I'm looking at the first term there, inverse cosine goes from 0 to pi. And because it's positive, that means it would be in the first quadrant. So I'm going to draw a triangle in the first quadrant here with that vertex angle there, or the vertex being the origin. And so cosine is opposite over hypotenuse. So that side would be 1, this side would be 2. Now by the Pythagorean theorem here, we could say 4 minus 1, that's 2 squared, minus b squared would be 3. And so this side would be square root of 3. Okay, now we've got cosine. Now we can find sine there. So sine of alpha is opposite over, or excuse me, yeah, opposite over hypotenuse. I drew that wrong. Back up. Yeah, I got the numbers in the wrong spot there. Cosine is adjacent over hypotenuse. So I put the 1 on the wrong leg there. There we go. Okay, and so now this side would be square root of 3. Okay, so now let's get it right here. So the sine of alpha is opposite over hypotenuse, so that would be square root of 3 over 2. And really and truly, we could have got that one off of the unit circle, because if we know the cosine is a half in the first quadrant, then the sine would have to be the other coordinate, square root of 3 over 2. Now the other one you couldn't do that way. And notice inverse sine goes from negative pi over 2 to pi over 2. Now since 3/5 is positive, it would go in the first quadrant, not the fourth. So if those were negative, like example here, if that was a negative 1/2, then you would have to draw it in the second quadrant. If this would have been negative 3/5, you would have had to draw it into the fourth quadrant. Now we got sine of beta there is 3/5. Sine is opposite over hypotenuse. And so by the Pythagorean theorem, that's going to make the bottom leg 4. And now we can say what the cosine of beta is. So notice I had to find those two things here before I could find the sine of alpha plus beta. I had to find the sine of alpha, and I had to find the cosine of beta. All right, so cosine of beta, cosine is adjacent over hypotenuse, and so that's going to be 4/5. Now let's fill all this in. So sine of alpha times cosine of beta, that's going to give me square root of 3 over 2 times 4/5 plus cosine of alpha times sine of beta. So recall cosine of alpha was a half, and the sine of beta right there was 3/5. Okay, so let's multiply before we add here. This is going to give me 4 square root of 3 over 10, and then 3 over 10. And notice I can't add a radical and a whole number there, so I'm going to have to write it as just 4 square root of 3 plus 3 all over 10. Okay, keep in mind, this is for, I think this is lesson 3-4 now, and this is due tonight.